Welcome back once again to the PLC Professor's Lab Workshop. This is where I develop the hardware end of my lab projects for my training manuals and some of the lectures. This particular lecture, we put it into the advanced, even though you could have probably watched it earlier on, but in this particular lecture, we're going to do as much mind dump on you as we can on tasks and programs, and maybe even subroutines. The RSLogix engine has much higher granularity than the 5 and 500 MicroLogix did. With those, you had one program, and that was it. There were no tasks. It was just a program. And inside that program, you could have multiple routines. You had a main routine, and in the main routine, you had to add the vehicle that got you to the subroutines. That's normal for computer programming. And these are jump to subroutine instructions. You can do that in 5000 as well. But where in the earlier products, you had one program and somewhat unlimited routines based on your memory, you take that format, that structure, and you put it into a task. But in the task, you can have 100 programs, each program having the data and the functional structure that you had in a 5 or 500. Which means in a Logix engine task, you have the equivalent of 100 structures, virtual structures of a Select 500 PLC5 MicroLogix. To further increase the granularity, you can have 32 tasks, each with 100 programs. And that gives you a total of 3,200 if you want structures. Now you're not going to do that. And there are some convolutions if you start to do that. First of all, there's only one continuous task. And you should know this already, having gone through the earlier course on all the basics, and that is that with the Logix engine, it does not have to stop what it's doing and go out and collect up the inputs, then go back and go through the logic, and then stop and send out the outputs. That's all done in the background. So the task, the continuous task, basically is trying to run continuously without stopping. Now there are some background things with data handling and communications and screen updates for your HMI, percent time slice. There's some things going on there that we'll get to eventually. But for right now, and you will find that people stopped using routines and started using multiple programs. I mean, if you can have 100 programs in the continuous task, and in the past for a system, you might have had 15 routines, a main routine, and then some subroutines. You can just do that with programs now. And then you put the programs in the order that you want them to execute. So let's jump in here and start discussing this lab project that you did. Welcome to the next lab discussion video in the series that supports the complete PAC Learn series, an introduction to RS5000 Volume 1. These lab projects were on tasks and programs. I like to refer to it as granularity. Welcome back to the next section of the manual RS5000 Volume 1. The next section is titled Tasks, Programs, Routines, Add-on Instructions. And this lab is more about the encapsulation or the boundaries of these different objects more than it is about programming. So this lab is not on making add-on instructions. The lab is on the architecture of a task made up into programs, programs made up into routines, and add-on instructions being used in routines and where they fit. So we had you open up RSLogix 5000 and create a new project. You can see where we ended up in the remote program mode from the last section. I will go offline. I don't have to go offline, I could just close it. So I'm going to go File, Close, shut that one down, and go to File, New, and we'll keep the L35E. We'll make it version 20, and it wanted us to title it Task, plural, and we want it in Learn RS 5000. So if you can create a folder anywhere you want, name it anything you want. I just chose Learn RS 5000 so I can differentiate projects that were saved from training purposes to projects that are saved from actual engineering that I do. We can click OK. And we already have one in there called Task. I think what I'm going to do is say no. And I'm going to add something on here that won't show up in your manual because I don't want to wipe out what I've already done. So I'll just give it a different name, task_00. Let me save it. Right now it's creating the file structure. And there you have it. Now remember, we've got our RS5000 constrained within 720 vertical and 1280 horizontal. So we kind of have to move around within that. So let's collapse motion groups because we're not going to do any motion groups. Let's collapse data types for right now. Now we can see the whole project in here, including our processor and the backplane. And this is the default code and memory configuration from RSLogix 5000 version 20. And this part of it right here has looked pretty much the same since the beginning. Here we have the main task, the main program, the program tags that belong with this program, and the main routine. So when you create a new project, it assumes that you will want, at a minimum, a continuous task. We know it's continuous because see the little swirly right there? The little clockwise swirly over there right next to main task. It assumes you want a continuous task. It is with one program called the main program, and a routine, the main routine, and we know it's main because of the little white sheet of paper with the dog ear on it, and there's a little ladder symbol behind it which tells us that it is ladder logic. We could change that. We could right click, go to properties, and we could change that. We would have to actually probably create another routine. I'll just do this for grins as long as I brought it up. New routine, and we'll make that a temp routine for temporary. Okay, now we'll go to program, and we'll go to properties. You couldn't see it, it was down off the bottom of the screen. We'll go to configuration, and we'll make the temp the main routine. Apply. Okay, now look, the temp shows a little paper and this one does not. So now if we go to properties, we still can't change it, but we could always delete it, maybe change it. So I'm going to go back to the main program, go out of your view where it says properties, configuration, and I'm going to make the main routine the main routine. So I'm going to get it back to normal. So that was just a little aside that we did. This is empty, so I can delete it. Now if there was something in there, that would be grayed out. Okay, since there's nothing in there, we can delete it. Okay, so it assumes you want a continuous task with a program and a routine and a tag database. You get the tag database whether you want it or not. So this is all default. The names of the tasks, the programs, the routines, and add-on instructions are subject to your whim. So you can name them as you please. In the manual, I included some excerpts from documentation on task, etc. I try not to do too much of that to burn up paper and book space. But the total allowable tasks, the number of tasks, varies with the processor family ranging from 4, 6, 8, or 32 total tasks. The tasks are each allowed a priority level, a priority of 1 being the highest priority. And I tell you right now, if you're going to go in and set priorities, avoid highly convoluted priority structures. Don't try to get too clever with how you set your priorities. And there are actually more than 15 levels of priority. So it appears when you look at this chart in your manual that it shows that you can have as many as 15 priority levels, and you can for these different tasks. So whether you have 32 tasks available in RSLogix or 3 tasks available in the L20 series, you still have 15 priority levels. Now, what would you do with 15 priority levels with 3 tasks? However, they just didn't change the structure to limit it to the number of tasks based on priority level. In other words, when you get below 16 tasks, like with the L35E, which is what we're using, we're allowed 8 tasks. Well, you don't need 15 priority levels. You have more than you can use. Now, for 32 tasks, you still only have 15. So it's 15 priority levels, except for Logix 5800, which runs on a personal computer. We call it a personal computer, but we mean a computer with we'll call it a public operating system like Windows. And although Logix supports 32 tasks, it only supports 3 priority levels. So moving on, there are actually more than 15 levels of priority, as you can see in the manual. It is worth your while to read through this list and think about the first 5 and the last, these of which you really have no control over. So the first 5, CPU overhead, the serial port and general CPU operations, motion planner, safety task, redundancy task, and trend data collection. You have no control over those. But then you begin with priority level 1, which you drop down to priority level 15, and then comes your continuous task. Now, it's good practice to put most of your code into the continuous task, keeping in mind that the continuous task tries to run continuously, but can be interrupted or suspended by almost any other task. The continuous task most closely mimics the program scan in PLC5 and SLC500 and RSLogix processors. Always put your code in the continuous task, and if it becomes a problem, you can always create another task with a higher priority later on and then move the code. Never pre-convolute your structure at the beginning, because you can always make it more complicated as you go, but if you start out making it real complicated, it's a real disaster trying to uncomplicate it once you've got everything running. Now, there's another little thing I put in there to do with percent overhead time slice. Very important. There will always be at least 1 millisecond of continuous task execution regardless of how high you set the system overhead time slice percentage. You can't set it to 100%. I don't even know why you would want to do that. But the background task remains at 1 millisecond until you set it higher than 50%. Because think about this. If it's 1 millisecond and you go above 50%, then you would be going below 1 millisecond for the continuous task, and you can't do that. So the jump from 1 millisecond to 2 milliseconds is forced by the requirement to have a minimum of 1 millisecond of continuous task. Now the background task, if you're a beginner with 5000 with a Logix engine, the background task would be things that you're doing for your HMI, your human-machine interface, data collection, etc. Okay, the continuous task, which is what we have here, the main task is continuous. See the little clockwise swirly. right-click on the main task, and then select Properties. You can read through. Take note here that you could create a new program in this task or a new equipment phase. You may also import a program or an equipment phase. But let's select Properties. Okay, in the Properties, you can rename it if you want. So we'll call it, just for grins, we'll rename it just so you can say you did. And we'll make it My Main Task. And then let's go to the Configuration tab. Now you can put in a description too. I had you put in a description. The primary location of machine control. We're just doing this to show that you can do it. Okay? Now we go to Configuration, and we want you to leave it continuous, but you could make it periodic or event. Okay, but leave it continuous. And I want you to see two things here. Disable automatic output processing to reduce the task overhead. Leave that as it is. Don't go in and do this right from the start because you're going to overcomplicate your process. Also, you can inhibit the task. If you, let's say, have written a continuous task and you create a periodic task, and you don't want the continuous task or the periodic to interfere with the other, you can inhibit any task you want, and it takes it right out of the game plan so you can concentrate on everything else. And in the manual, I show you a structure to explain this process. So it is not necessary to update the output modules at the end of every task execution and at the RPI that you set during configuration. RPI is the requested packet interval. You can check this box to increase the system resources for other tasks, and your output module will still be updated at your configured RPI. You may also inhibit the task from executing while you are commissioning the system to eliminate nuisance fault from untested code. Okay, now select Program Phase Schedule. Okay, so we only have one program, the main program, but you can, if you have more than one program, you can move them up in the order that they execute here. You can actually unschedule them if you don't want them to run. See down here where it says unscheduled programs and phases? You can temporarily or permanently unschedule a program. It takes it right out of play. Now, until we have multiple programs, there's not much to look at here. So remember to go back and look at this later on when you have multiple programs. But keep in mind the latitude provided here for you. Not only can you change the order of program execution, you can inhibit a program or programs by simply removing them from the schedule. This does not delete it. It is suspended from execution. This, like I said, is very handy when you're commissioning a system. Now select Monitor. This is a nice feature. Of course, there's nothing there because we're not online. Again, this is not very impressive because we are offline and there is nothing to monitor. However, you can see that this is where to go to check on the maximum scan time and the current or last before some major fault. Also, the intervals between scan triggers. Keep in mind that we have a continuous task. We don't have an event or a periodic. So when we talk about triggers, that's not necessarily as relevant. Now, an overlap occurs if a task is interrupted and then triggered again without having finished the last scan. So these are excellent troubleshooting tools. And you're thinking, well, why would I want to know that? Well, if you create periodic tasks and you have them run too often and they're too large, they will overlap. You would have to go in then and stretch out the intervals between their triggers so they're not overlapping. Once you begin running your code in the remote run mode, you should return here periodically to monitor the task. The more often you open this tool, the more likely you are to remember that it is always available to you online. Okay, we're done here. We didn't change anything, so you don't need to hit apply. Just hit OK. And now go to the main program. So we looked at the properties of the main task. Now go to main program, right click. It's down off the screen, but down here at the bottom is properties. Okay, and so we're going to change the name of this just for fun, and we're going to call it my main program, and we'll say routine sequence and control. Which is pretty much what people normally put in there. Then go to the configuration, and in the configuration we've already looked at this. This is where you selected which routine is your main routine and which routine is your fault routine. So we only have one routine, and it's selected for the main routine, so we can't select anything for the fault routine. Notice also that we have an inhibit program box. So remember that a task can have as many as 100 programs. You could actually write a program and then change your mind about the structure, make a copy of it, so you have two programs, they're identical, but then you edit one of them with a new structure. You go in, you make some modifications. You can inhibit one and only run the other. So you see some advantages for commissioning and troubleshooting here. Okay, so under the configuration, you can select which is the main routine and which is the fault routine, and you can inhibit the program. Currently we only have one routine to select, so we can't actually do much. And people do write special routines for just for fault handling. Okay, now select monitor. And again, this isn't quite as vast as the monitor from the task, but you can individually, for each program, and again, this is not very impressive because we're offline and there's nothing to monitor. However, you can see that this is where to go to check on the maximum scan time and the current or last before some major fault. This is another excellent troubleshooting tool that you really didn't have in RS500. Okay, so nothing changed there. We'll hit OK to close that box. Now we'll go to main routine. Right click and go down to properties, and we can rename this. So just for grins, we'll call it my main routine. Real clever, huh? We can enter any description you like. My favorite one is blah, 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 blah. So put anything in there you want. Rename it just because you can, if you like. And say OK, because we did actually change that. So see, now we've got my main task, and in my main task we have my main program, and in my main program we have my main routine. So you can name these anything you want. Now, the ladder symbol identifies the routine's language. I mentioned that before. See, it looks like a ladder behind the little main routine sheet. It identifies the routine's language as ladder logic diagrams, and the sheet of paper with the 1 indicates that it is the main routine of the program listed right below it. Okay, now let's look at periodic task. Okay, so go to task, not my main task, but task. And there is only one, my main task. Right click, new task. Ooh, periodic's already selected. Now, why was periodic already selected? Well, why isn't it continuous there? Because you can only have one continuous task. It knows that. And so it's not going to give you the choice to select something you can't have. So we'll call it temperature control. And we'll describe it, logic to control the temperature of the process. I did learn to type in high school. Of course, that was a million years ago. And the only reason I took typing was because that's where all the girls were. I walked by one day, I looked in there, and all the babes were in the typing class. So next semester I signed up for typing. Now, I meant it for evil, but it turned out for good, because I am oh so thankful that I can type. Not just because it helps to be able to type in when you're programming a PLC, but also when you're creating documents and doing emails and everything else in life. Typing is really an essential thing. So, new task, temperature control, logic to control the temperature of the process. And we'll leave it in the default form. Let's leave the period at 10 milliseconds for now, as well as the watchdog timer at 500 milliseconds. The two boxes to check serve the same purpose that they did for the continuous task, as far as reducing task overhead and inhibiting the task. Now, the watchdog, that means that if it's executing this task and it takes more than 500 milliseconds, it's going to fault with a watchdog timer fault. In other words, it's taking too long. And you select this based on what you expect. So we'll click on OK. Now we'll go to temperature control, which is a task, right? But notice it didn't create anything else for you. So we'll, because you might want an equipment phase, but we'll create a new program, and we'll call it main temperature control. We're not trying to be too clever here. Main temperature control. Hope I spelled that right. And then we'll describe it. Logic to control process temperature of area A1. Okay, so we're getting more specific. Click OK. Oh, look, now we got a program and program tags, but look what we're missing. No routines, right? Not a problem. So now we right-click on main temperature control and select routine. Now we could import a routine that we've already created specifically for temperature control. That's the beauty of this whole structure. New routine. And this new routine we're going to call Event Program 1. This one's going to be called Main Temperature Routine. And we'll label it, we'll give it a description of routine sequence control and startup. We'll select a language, and we'll leave it ladder logic for now. And we want it in the main temperature control, and the assignment is it's the main routine. So we click OK. So now we have two tasks, my main task and temperature control. One is continuous and the other is periodic. Now the format of the two programs looks identical, each with their own program tags and each with their own main routine. By now you probably noticed the symbols on the task folders. Clockwise swirly for the continuous and a clock for the periodic. If this is an L35E processor, which is what we selected, it is allowed a total of 8 tasks. Okay, what we haven't done is an event task. Every once in a while one of my papers falls and I have to grab it. Sorry for the interruption. Event task. So let's go create another task. So we go to task, right click, new task, and we'll call this my main event. I'm sorry, make it an event, and we'll leave it in event instruction only. Now we could get clever here and pick different kinds of events like access registration from your servo system, motion group execution, a consume tag, so you can actually set up a produce consume tag. In other words, you produce a tag from another controller and then you consume it in this controller, and that triggers the event task. but we'll leave it event instruction only for now. Logic to execute when my main event occurs. Probably a waste of time to make you wait while I enter the information, but it's what I had you do in the book. Okay, not every application has the processes to use some of these triggers that I showed you, such as motion-oriented I/O modules that have change of state configuration, etc. So you can select to automatically execute the task if the trigger has not occurred within some set interval. That was one of the properties that you could have changed. So let's go to My Main Event. Now look at the symbol here, see? Clockwise swirly, periodic, and that is the symbol for an event task. So we go to My Main Event, and we select New Program. We name it Event Program 1, and Logic to execute on Event 1. And we say OK. So we named it, described it. Look, you can inhibit it if you like, as with any other program. So we expand that. We've got the program tags, but no routine. Within that program, within that task, we can then go and, I think you've got this all figured out by now. In that program, new routine, and we'll call it My Main Event Routine 1. And for description, routine sequence control, and we'll leave it ladder diagram, and we'll just click on OK. So now you see we have three structures that look very close to the same. Now in the RSLogix 500 platform, you can do this with conditions preceding a jump to subroutine, a JSR, executing the code only when the event monitored with an instruction occurs. So you can simulate some of this in RS500, but not as cleanly and not as controllable, and you don't have all of the inhibits and structures to manipulate for commissioning. Also in the RSLogix 500 platform, this is the environment that your codes execute within. So the continuous task here would be the closest to what you have in RS500. And a periodic task, so a main event, the event task, you could simulate in a 500 with conditions preceding a jump to subroutine. Whereas the main routine in RS500 would be like the main task here, the continuous. Because in a SLC 500 PLC 5 MicroLogix, there is only one task, and it's continuous. The temperature control periodic here, you could simulate this by using a timer to jump to a subroutine on a regular interval to execute the code on the leading edge of the interval of the preset value. However, you cannot easily reuse code without the granularity that the database of the logic engine provides. You'll see this as we go along, that there's some features of granularity, meaning within the RS500 realm, you only had one, if you want to call it, tag database, and everything was there. You couldn't reuse anything. You couldn't use the same tag twice. Whereas in 5000, you have granularity. You can reuse the same tags. Now in your book, I kind of took you through a couple diagrams. The first one showed memory for PLC 5, SLC 500 MicroLogix, and really any other PLC. There really only is one program file, one data file, and usually some unused memory. There are no invisible boundaries between unused memory, the program file and data file. Or there are invisible boundaries, but these boundaries shift as you change the size of the program and you increase or decrease your I/O structure. But think of it as a single entity in the sense of processing and data storage. One brain, if you will, working by itself with some I/O provided and the ability to pass notes to entities in other locations by message instructions or in and out of other environments. No eye-to-eye contact, no intimate transfer of ideas or knowledge. You just pick up a can with a string on it, pull it tight, and yell into it, and someplace else, somebody sees their can move, they pull it up, pull their string tight, put their ear in there, and they listen, and then you talk by message instructions, the old 2 tin cans with a string tight between it. Now, the other diagram in your manual showed a task with 3 program files and a common data file, which would be your program tags, and then each program file had a data file. Think of that diagram as 3 instances of the memory in RS500. So if you took RS500 and duplicated it 3 times, pulled out the I/O, which has to be in the controller tags. Each instance has 1 program file, 1 data file, and more memory available if needed. There are invisible boundaries between each instance. Think of it as 3 entities in the sense of processing and data storage. 3 brains, if you will, working autonomously. Now we're describing these 3 tasks right there in front of you on the screen. My main event, my main task, and temperature control. These are 3 completely individual entities. So think of it as 3 entities in the sense of processing and data storage, 3 brains, if you will, working autonomously with some I/O provided and the ability to communicate directly within the same environment through the controller tags. Eye-to-eye contact and intimate transfer of ideas and knowledge. 3 brains, each autonomous, yet in a common environment. Go a little further with this illustration. These 3 brains are in the same room collaborating. There is an order of magnitude in processing results with this type of a processing environment. Whereas the I/O of which a controller is not a controller. So where's the I/O? There has to be some I/O. In your manual, I continued on with some more diagrams. If you have your manual in front of you, I won't tell you what page it's on. It's page 62, but that can change as the manual gets updated. But it's the next diagram that shows digital input-output modules, analog input-output, Circos motion control, and a network bridge. And they're all plugged into the same backplane. I also show 2 processors, and each processor has 3 tasks. Well, each processor has, a task, and each task has 3 programs. Either one of these 2 processors, all the programs, all 3 of them have access to the common data file, which is controller tags. And controller tags is the stopping point for any data that's going to go out on the backplane or come in off the backplane. If you wanted to produce data from the first processor on the left to the last one on the right, there's I/O modules in between, so there's only 2 controllers. You would create a tag in the first processor, and you would identify it as a produced tag. Well, then it would say, okay, if you're going to produce it, who's going to consume it? You would then have to define the path across the backplane over to that other controller, and then in that controller you would create a tag and say it's consumed. You have to create all this ahead of time before you actually run the program. Then when you run the program, the producer sees that it's a produced tag. It follows the path over to the consumer and says, hey, do you really want this? The consumer says, yes, I do. So the producer starts producing it at it will produce it at the requested packet interval or faster. And so the actual packet interval is called the API, the actual packet interval, which is always faster than the RPI or equal to. Now, at this point, this is really a spot for a lecture on this subject. So I'm going to not elaborate anymore on all of the details I put in the manual for you specifically on this structure, because at one point I get up to 3 controllers each with 3 tasks, each with 3 programs, and then I show bridge modules between the backplane and netlinks, which would be device net, control net, or Ethernet IP. So the diagram gets real busy, almost too busy but I really wanted to make sure that you grasp what's going on with tasks and their programs and their relationship to controller tags, producer, consumer, and across the backplane. Thank you for watching this lab discussion video.